To verify a trig identity, you need to make one side of the identity look like the other side. Now, not that these will always work. Sometimes, you can't say, oh, this is step one, this is step two. No. Try to rewrite the more complicated sides. Sometimes you'll need to work both sides in order to verify the identity. Expressing trig functions in terms of sine and cosine is sometimes helpful. Not always. Sometimes it actually makes the problem more difficult. Look to factor or perform any algebraic operations. Verifying identities is not the same as solving equations. Techniques such as adding the same term to both sides should not be used when working with identities because the identity might not be true. You're trying to prove that it is. Okay, so if we go with use a side that seems to be more difficult. Okay, let's continue. These are usually easier written in the middle so that you can write on both sides. So I'm going to bring a line down. Okay, should be much straighter. And we're going to use identities. This is not one where you can go, oh, let's multiply both sides by secant squared. No, you work on one side or the other. You cannot move things around. I'm going to play with the top. This is a Pythagorean identity. Tangent squared plus 1 is secant squared. I'm going to put it on this side because it was a Pythagorean identity. And then secant squared, remember this means there's two of those, so this guy cancels with this, and you're left with secant of theta. And that was an algebra step. I'm just going to write algebra. And if I bring this guy down, secant of theta equals secant of theta, and we're done. Using trig identities, and only really one, I would prove that this mess equals this guy. Okay, let's try another one. Some of these are going to be really fast, really quick, really easy, where others we may find ourselves taking some time on them. Okay, I'll do the straight line this time. Okay, so on this one here, I want to point out that secant sine squared plus cosine squared equals 1. So this gives me 1 plus tangent squared. I use the Pythagorean identity to get there, tangent squared, and 1 plus tangent squared, using again another Pythagorean identity, is equal to secant squared. Okay, choose at least stick with the same variable. And I bring this guy down, and lo and behold, there it is. Secant squared of x. Done. Okay, again, knowing your identities, you're going to get through this faster, and if you, of course, algebra. Okay, the next one. Again, I'll bring down my nice clean line here. Okay, what I'm going to do here is first thing I'm going to do is that funny factoring. So that gives me cosine of theta over sine of theta. Yes, I'm going to leave it there. Times 1 over cotangent of theta. I just put these two together, cosine over sine, and cotangent. Now, if you don't recognize it right offhand, the idea here is that you should look at this, oh, cosine over sine, that's cotangent, and just go there. So I'll put to the side that I did the funny factor because I took my, I separated my fraction. My next one will be a quotient identity. Cosine over sine is cotangent. 1 times 1 over cotangent. And I can use reciprocal identities. I can use algebra, however you want to look at it, because these two babies cancel out and you're left with 1. Both sides are the same. Okay. All right, and the next one. more than one way to go through these, but I'm going to get rid of this first. This is a Pythagorean identity. Write my line down. So this is going to be sine squared of theta. 1 plus cotangent is cosecant squared of theta minus 1. Pythagorean identity. Next, I'm going to use a reciprocal identity. This is sine squared of theta times 1 over sine squared of theta minus 1. Again, reciprocal identity, algebra, whatever you want to use it. But these guys reduce and you're left with 1 minus 1, which is 0. This is straight out math. And we bring the 0 down on this side and go, look at there. They're exactly the same. Okay, now that we've done some easy ones, let's try a more difficult one. Okay, so I need to get 1 over secant minus tangent to be secant plus tangent. You may see some people will look at this one going, oh, the left-hand side looks difficult. Some will say the right-hand side looks difficult. No matter how you look at them, they're both difficult. So on this one here, I'm going to change secant and tangent to sine and cosine. So do I want to call them? I'm going to be using the reciprocal identity, and then I'm going to use the quotient identity. So this becomes 1 over cosine minus sine over cosine. What's nice is that they do have a common denominator here. So you have 1 over 1 minus sine over cosine. We'll just write this as an algebra step. Okay, now we have a nice little complex fraction. 1 is in the numerator and the rest is in the denominator. So we're going to multiply by the reciprocal on top and bottom. Cosine of x over 1 minus sine of x on top, all over cosine of x times 1 minus sine of x. These guys will cancel out, which is exactly what we want to, which leaves us to cosine of x over 1 minus sine of x. And then we sit there going, okay, so what do we do now? This is why it becomes harder, because a lot of people will go, I don't know what to do at this point. And that's where some people would be, they would be stuck there. Now, this is where if you get stuck, you can always come to this guy and go, okay, let me play with this guy. Secant is going to give you 1 over cosine of x plus sine over cosine, which gives you 1 plus sine of x over cosine of x. Still not the same. I'm not saying it didn't help, but it doesn't look like it's helping us. But by the way, we did the same as the other side. Reciprocal identity and a quotient identity. Here was just a nice little algebra step. Okay. So, but I need to figure out something here. Now, we can't use Pythagorean identities because nothing's squared. However, this is part of those identities. So what I'm going to do is multiply top and bottom by 1 plus sine of x. Multiply by the conjugate, you're going to get a difference of squares on the bottom. So this is, believe it or not, it is an algebra step. So again, we're multiplying these two fractions. 1 times cosine gives me cosine of x, and then sine times cosine plus sine of x, cosine of x. I'm wondering if I need to do that step. We're going to backtrack a little bit. Oh, that is not what I wanted. That scared me. I just want to redo this one. We're going to leave the top alone. Cosine of x times 1 plus sine of x over, and this is a difference of squares. We're going to get 1 minus sine squared of x. Okay. For those of you going, wait, what? 1 times 1 is 1. 1 times negative sine. Sine times positive 1 gives you 1 sine, negative sine. They cancel out, and then sine squared. This is where I get to use my Pythagorean identity. 1 minus sine squared is cosine squared. Okay, so cosine of x times 1 plus sine of x over cosine squared. So we continue this down. Extend this line. We're almost done. Because I have a cosine here, and which cancel out with this guy there. So this gives me, so we can reduce algebra, whatever you want to call it. I get 1 plus sine of x over cosine of x. And this is where I get to remind you up here, look what we have, 1 plus sine of x over cosine of x. So this is what they mean by, sometimes it helps to do the both sides, because the goal is to get both sides looking the same. We're done with that one. That one definitely was one of the more difficult ones that you will get these. And you do need these for calculus. That's the big thing, is that you do need these for calculus. Okay, probably the multiplying by the conjugate. Remember the conjugate 1, if it's a binomial, you change like this one here, 1 plus, multiply it by 1 minus, and you're going to get rid of those in between guys, and it's going to get you to Pythagorean identity. And that was the purpose of that one. Okay, next one. So a lot going on here. See, now this is where if I was teaching this in class, I would be going, all right, guys, do you want to start on the left-hand side, or do you want to start on the right-hand side? Which way do you want to do this? We will probably end up playing both sides at some point. I'm going to play with this side because I want to get rid of the fraction. Get rid of the fraction by multiplying by the conjugate. So this is plus, so it's going to be 1 minus sine of x, 1 minus sine of x. Okay, so you're going to FOIL this out. 1 times 1 is 1. Negative sine of x, negative sine of x. 2 negatives make it positive, plus sine squared. Over 1 times 1 is 1. 1 times negative sine of x. Positive sine times 1, positive sine of x. And sine times sine, 1 positive, 1 negative gives us a negative sine squared. Okay, so combine like terms. So I get 1, negative and a negative, so negative 2 sine of x plus sine squared over, and these two guys are going to cancel out, so you're going to be left with 1 minus sine squared of x. And this is where we use Pythagorean identity, so we get 1 minus 2 sine of x plus sine squared of x over cosine squared of x. And almost feel like we got at a standstill here because I'm going, well, I can do this, this, and this. I'm probably almost there, but I'll probably find it maybe a little bit easier to work the other side. Here's one thing to know. There's not always one way of getting to the answer. I can continue finishing down here, but it's a lot of algebra, not that this isn't, but this is probably a little bit easier algebra to see. This one here, secant minus tangent squared. A rewrite, this is just secant of x minus tangent of x times secant of x minus tangent of x. So first thing we're going to do is FOIL it out. Secant times secant is secant squared. Secant times tangent, negative secant tangent. Negative times this gives you negative secant tangent. I brought it down because I'm running out of room. Negative times negative gives you positive tangent squared. So this gives me secant squared of x minus 2 secant of x tangent of x plus tangent squared. Now the only thing I can truly, combine like terms, say about the 2 is that I have a perfect squared minus 2 of something plus something squared. And we have the same thing, something squared minus 2 times something plus something squared. But these are sine and cosine, and this is secant and tangent. So we're going to do a lot of identities here. On this one, I'm going to do a reciprocal identity. This one, I'm going to do a reciprocal identity. This one, I'm going to use a quotient identity. And this one, I'm going to use a quotient identity. That way you know what's going on in each of these. So secant squared reciprocal makes it 1 over cosine squared minus 2. The secant becomes cosine. The tangent becomes sine over cosine, which becomes cosine squared, plus sine squared over cosine squared. And we get to look at this one going, oh look, I have a common denominator in the bottom. Oh look. So let's rewrite this. So rewrite, I'm not doing anything special. 1 minus 2 sine of x plus sine squared of x all over cosine squared of x. And we have exactly the same. So again, I could have continued down here and rewrote this all as 1 over cosine, blah, blah, blah. But I don't know which way would have been faster, simpler, or easier for anybody. Okay, next one. Okay, so bring our line down. All right, so we got a lot going on here, but I do want to point out this is a perfect square because it's an even number. Mine is a perfect square again because it's an even number. So if it was x squared minus y squared, we write it as x plus y, x minus y. To the fourth, it would be if we just use the square part. So in algebra terms, if you had x squared, no. Again, if you had x to the fourth minus y to the fourth, it would be factored out as x squared plus y squared times x squared minus y squared. And that's what we're going to do to this numerator. So it's a difference of squares. This is the idea. I have something to the fourth power minus something to the fourth power. This is what it's going to factor out to be. So I'm going to write over here. All I'm doing is factoring. So this becomes sine squared of x plus cosine squared of x times sine squared of x minus cosine squared of x all over sine squared of x minus cosine squared of x. And at this point, you should see that these are going to cancel out. So reduce. And I'm left with sine squared of x plus cosine squared of x. And if we use a Pythagorean identity, sine squared plus cosine squared equals 1. Bring this side down, 1. And you can see there's a lot of algebra going on in these. And so you've got to know your algebra as well as you have to know your identities. Okay, we got one more. This one's going to be a doozy. You guys go. A lot going on here. Oh, this isn't what I have down as the last one. I've got some missing out of my notes here, or like I have a whole page of notes missing. Okay, here's the one to try. We can see that this one is very simple on this side, where this one is not very simple on this side. What we're going to do, before you can do anything in this denominator, each of these denominators have to have the same common denominator. So there is a lot of algebra going on here. So we're going to make a note that we're only going to play with this part for now. This is what I would call side work. But this guy here is going to become sine minus cosine okay, sine of theta minus cosine of theta over sine of theta all of this is going to be sine of theta, okay, plus, and then you have cosine of theta over cosine of theta minus sine of theta all over cosine of theta. Okay, seems like a lot. I know this seems like a lot, but we're going with it. Now, we have to keep these two separate. By the way, we just got a common denominator. That's all we did. Please, common denominator. There you go. Okay, this is the numerator. This is the denominator. And if you have the fraction in the denominator, this guy here really goes in the top. So we're going to have sine squared of theta over sine minus cosine. Same with this one, the cosine is going to come up top, so plus cosine squared of theta over cosine of theta minus sine of theta. Okay, now what we cannot do is go, oh, just a minus sign. We can just, no, we can't do that. we can make one itty bitty little change. And I can rewrite this guy or this one either way. So sine squared of theta over sine of theta minus cosine of theta plus cosine squared of theta over -1 sine of theta minus cosine of theta. All I do is factor out the -1, but in a fraction, doesn't matter where the negative sign is as long as it's there. So I'm going to move this negative sign up here. So I now have sine squared of theta minus cosine squared of theta all over sine of theta minus cosine of theta. Okay, almost done. Promise. Almost done here. Because this one here, there's your difference of squares. Notice that I've used no identities throughout this whole thing. This is straight out algebra. A perfect square minus a perfect square. This is where I get to remind you that the x squared minus y squared is x plus y times x minus y. So this becomes sine of theta plus cosine of theta times, sorry, fraction bar got carried away, sine of theta minus cosine of theta all over sine of theta minus cosine of theta. Those two guys cancel out. And we are left with this guy being in the way. And we're left with sine of theta plus cosine of theta. So I can bring this guy down. And sine of theta plus cosine of theta. And we're done. Because I can claim this guy here. And we are finished. Another very, very, very long video. So this will be 5.2b. Please label your homework correctly. Good luck.